Okay, students. So we have already finished the main theory part. Today I was supposed to start with the problem, but in between, let me try to tell you that I forgot about the very important part of functions, that is your graphs, right? Some standard functions are there whose graphs we must know, right? So we are going to draw the graph today. Those graphs we will study today, and then next video we will be doing the problems, right? By that time we might start, like Sanjay sir might start the next chapter. Anyway, let's start with the graph. So the very first graph we are going to study is the identity functions graph. Okay, before that let me try to tell you how to draw the graph of a function, right? First we have to see that, then we will be starting with the graphs, right? Suppose your function is y equal to fx, right? Fx, it will have some like expression, right? So now we write y equal to fx. You can see from the explanation of domain in the range, right? So here this is the key where we'll be getting the points, right? Because to draw a graph you need the points. So if you construct a table, then the value of x as per the domain permits, this value you have to take for x, right? Got it? And then corresponding value of y is nothing but value of fx. And then once you get these points, you can draw the graph very clearly, right? So this is what we are going to follow for constructing a graph of the functions, right? So first function we are going to take is the identity function. So you must know what is identity function as well. So I'm writing the identity function first. Alright, these are all real functions, right? Identity function, right? Identity function. So identity function is a real function f from a real number to real number such that, right? Such that f of x equal to x for all x belongs to a real number. Means identity function is such that whatever is the input you give, it come out exactly as the output. Whatever, if you give input as 1, you will get 1, 2, then 2, right? Like this. One more thing, I have written f, but normally identity function is represented by I, capital I, right? So I could have written this as I from R to I, right? Just try to understand that, because next time onwards I'll be using I for the identity function, right? So now we are going to draw the graph of this. I'm going to just do it very roughly, so I'll not write statement, not needed. Only you need to know the graph, right? So first of all we are going to construct a table, right? Without table also we should do actually, but just for glimpse how to start with, we have drawn a table here, right? Suppose this be the table. Some of the points will take, this is the value of x, this is y, which is nothing but f of x. Here you can remember that whatever is the entry, that is the output, right? So you can take some negative numbers, you can take 0, 1, 2, right? Am I clear to you? So now just let us try to draw the graph. Right, these are the axes. So I'll not mark all y-axis, x-axis very clearly, right? So now just go on putting these points. 0, 0 is here only. Okay, minus 1. Suppose this much is minus 1, so this will be minus 1. So point will be lying here. I am not dividing every point here, right? That scale I am not dividing, because I am going to construct a rough figure, which we must know. The next point is 1, 1. So this side 1, above 1, like this. Then 2, 2. Now anyway, from here you can easily get the idea that whatever you are going to get, right, after plotting the points, these are such a point where abscissa and ordinate both are same, right? So in that case, if you join them, by a line, right? This will lie always in a line. Then you'll be getting a straight line passing through the origin, and it will make angle 45 degree here. That also you can verify just by drawing a triangle here. That is not needed, just listen that it will make angle 45 with x-axis and it is passing to the origin, right? And it is in the first and the third quadrant. This is enough, right? After that, can you think about its domain in the range? Domain is already clear. It is a real number. What will be the range? See, here identity function tells you whatever is the input, that is the output. So whatever is the input, that is the output, means domain is real number. So output will be also real number. Means your range is also real number. That means here codomain and the range are both matching. So this is about the identity function. Now let's go for constant function, right? We'll be going for constant function. Let us try to understand what is a constant function. Constant function means no matter whatever is the input, you will be always getting a fixed output, right? Because of that it is called to be constant, right? So let's see. This number 2, suppose constant function. A function f from real number to real number. See, always these are real functions. Such that f of x equal to some constant. K is a constant for all x belongs to the domain, right? For all x belongs to the domain. Now we are going to draw the graph of this. So anyway, like the previous one, we have to draw a rough table. So if you try to draw the rough table here, no matter whatever is the entry for x, why you will be getting, say 1, 2, 3, minus 1, 0, you will be getting this as k. Now here I am not putting the value of k. Suppose k is 4, right? Suppose k is 4. So it may be minus also, it may be 0 also, right? I am considering only one value for the example. Suppose k is 4. In that case, the first point will be 1, 4. Say 1 is here, 4 will be here. Okay. 2, 4. 2 will be here, 4 will be here. Then 3, 4. Then minus 1, 4. This side also, if you come, your height remains same, right? What does that mean? For constant function, if you try to draw, always the height will remain same. That is, distance from the x-axis will remain always same. If it is positive, it will go above x-axis. Negative, it will come down. And if it is 0, it is x-axis itself, right? So here I did not specify. For example, I have taken k equal to 4. In that case, your graph will be like this. And this distance is how much? Always 4 unit here. In my case, example. What do you observe here? You observe that the line is parallel to x-axis. So, constant function's graph is always parallel to x-axis. Now you come to the domain in the range. What is the domain? Domain of the function is the real number itself. This whole thing. What is the range? Codomain is also real number. But what is the range? Range means it is containing that value which is output. What is the output here? If I talk about, it is k. So singleton value, singleton set k is the required range. Am I clear to you? So this is the graph of constant function which is always parallel to x-axis, and domain is the real number and range is a single point, right? So let's move on to the next graph. Number 3, next graph is polynomial graph, right? Polynomial functions. Polynomial functions. Number 3, polynomial function. Right? Polynomial functions. So polynomial functions can be of many types. Right? Can be of many types. It may be linear polynomial, quadratic polynomial, cubic polynomial. So we'll be having different form of graphs. So we'll be not fixing any particular polynomial, right? So just I'll give you general form of the function, and then we'll proceed for drawing the graphs in a nutshell, right? So a function f from real number to real number such that y equal to fx, right, a polynomial, right, a polynomial, right, is called a polynomial function. It is called a polynomial function. Every polynomial, if expression is any polynomial, then that is called polynomial function, right? What is the output? It's a polynomial. Now just you see, very quickly I'll discuss this. So you can easily compare also from your class 10. Polynomial, let me start with first thing, constant polynomial, right? Constant polynomial means this will become a constant, so it will reduce to the constant function. So graph will be what? Parallel to x-axis. Its graph will be parallel to x-axis, right? Positive above x-axis, negative below y-axis, x-axis, and 0 means the x-axis itself. Okay, constant polynomial means it excludes 0 itself. Remember it, the value 0 is being excluded. Please try to remember that. Constant polynomial I am talking about, right? Not constant function. Then next is linear polynomial. Linear means single variable. Linear polynomial, ax plus b type, so it is ultimately what you will see. I'll do a rough for you. Fx means y and ax plus b. So what you remember from this is actually a linear equation in two variable. So if you draw the graph of this, what you will get? A line you will get. You don't know whether it is parallel or perpendicular to x-axis or y-axis. It may be inclined, right? So it is a line, a straight line, right? In graph it will represent always a straight line, linear polynomial. Then you come to quadratic polynomial. Quadratic means degree 2. Quadratic polynomial. If you recall your class 10, already you have drawn the graph of quadratic polynomial, right? So it is a parabola. It's a parabola, either like U type or like this, what I say, like the umbrella type. Okay, so this is known as parabola, right? So graph is a parabola. Graph is a parabola. So what is the format? Either this or this type. Parabola, there are two more types. Why they will not be there, I will not discuss it now right at this moment, but I will discuss it afterwards. Now you come to cubic. There are many cubic polynomials. So every cubic polynomial will have a particular graph format, right? The graph will be like this, right? Or it may be, I will not disturb that. Okay, I have to disturb them. I will do it a little far, right? Either like this or maybe like this, right? There will be two such turning if it is cubic, right? If it is cubic, once you draw the graph, there will be two such turning. Now I will not discuss further, just let me give you hints. If it is biquadratic, that means power is 4, then there will be three such turning, like this or like this, right? Similarly, if degree is 5, there will be 4 such turning. That's the idea it will go, right? So this is all about the polynomial function. After that, we will come to rational function. Rational function. Number 4. Rational function. Right? Rational function means it is of the type of division by two polynomials. Two polynomials, right? Say, if I write fx equals, say, one polynomial gx divided by another polynomial hx. These polynomials are from real number to real number, and you have to exclude from here the domain, from the domain those points where this denominator comes out to be 0, if any, right? So in that case, any such expressions, rational expression having both as the polynomial is called rational function, right? So be very careful about that. These numerator, denominator are necessarily polynomials. But here I cannot draw a particular graph because you may be having many choice of the polynomials. So whenever we get a particular polynomial, then only we can try to draw the graph. So here I am not taking any graph. But of course, in some time after, I'll be giving you the graph of, say, 1 by x is what, 1 by x square is what, like this we'll be discussing. Okay. I'll be preparing one separate video completely on tracing of graphs, right? Okay. Now, after that, right? After that, we'll be coming to a very important function. Number, I think 5 it will be modulus function. Modulus function, right? What is modulus function? It's a very important function. Make sure that you get everything very, very clear, right? Nothing should be confusing. No confusion should be left out. If any doubt is there, definitely clarify it. A function f from real number to real number such that fx is defined as modulus of x for all x belongs to R is called the modulus function. Is called the modulus function. Now here I have to say what is modulus, right? Where modulus means it is what? Absolute value of x. Absolute value of x means the numerical value. If it is -3, we should take 3. That is modulus of -3 is 3. Modulus of 3 is also 3. Right? So we do not consider here the sign. We make everything positive. This is the category of modulus sign, modulus function. So this is what we already know. But now we have to redefine it in a different way for class 11. Right? So that we will not be confused afterwards when we use this particular simulation. So what we write? Modulus x will write as x if any positive input we give. If you are giving 3 inside the modulus, your output is 3 only. So it remains same. So if it is positive, your output is same. If you give a 0 input, 0, what is the absolute value? Numerical value? 0 only. If you give something which is negative, something which is negative, it should be made positive. Modulus makes everything positive. So if you put minus 3 inside the modulus sign, you should get 3. Here too, as it is a number, we can see the minus sign. We drop the minus sign. But that is shortcut actually. The main process is that to make that number negative, that negative number a positive one, we do not drop negative sign. Rather, we introduce one more negative sign. Negative of negative 3 is positive 3. Right? So just I explain before I write this. Suppose somebody asks you modulus of minus 3. We write it as 3. Okay, there is nothing wrong. You can write it. But the process behind it is this only. But we skip this step. Because it is numbers, we can do it. But when it is like this, where negative sign is not visible, to make it positive, we put a negative sign here. So this part is very, very important, because I am telling you, earlier I have noticed many children, they used to avoid this, or they somehow skip this, because of which when they get into class 12, they find a lot of difficulty in chapters called limit and continuity, right, and differentiability, and many more things, right? So be very careful about this. Please make sure that you understand this. Now we are going to draw the graph of this, right? So here also we'll be observing some rough points, and then we'll be transcripting this into a graph, right? So I remove this part, right? So first let me draw a rough table. A rough table I'll construct here. A rough table I'll be constructing here, right? So in that table I have 3 categories of numbers here, right? One positive, one negative, another is 0. Please make it sure. Okay, 0 let me keep here only. So if you put 0, then output will be also 0. Negative numbers you put, output is positive. Minus 2, 2, minus 3, 3, 1, 1, 2, 2, 3, 3. See, you can take bigger values also. I took smaller so that I can draw the graph little comfortably, because I have less space. Here, do you observe one thing? There is a very important peculiarity. All the values what you got as the output value of y are either positive or 0. So now just try to observe where the values of y's are positive in the graph. It is above x-axis, right? Below x-axis, whatever points are coming for y, that are all negative. So this means this particular graph will have nothing drawn below the x-axis. Everything will be entirely lying above x-axis with a common point with x-axis, then 0, right? So let's see how it happens. So how it happens? So very clear, right? So we'll draw the axis. Fine, we have drawn the axis. Now you go on plotting the points. First of all, 0 we can put here. Positive points 1, 1 here, 2, 2, 3, 3. Negative points minus 1. Remember identity function, it was down, but this time it is positive above. So what did you notice here? Moment you come closer towards 0 from positive side, you are going to get this line, and then here if you find from the negative side, you are going to get this line. And because the coordinates are at equal distances from the axis, whether positive or negative, forget about that. These two angles are both 45 degrees. So it's a structure which is looking like a V, right? Which is a V, where both the arms of V are making 45 degree angle with the respective positive and negative x-axis, and the angle in the V is 90 degree. So this is what the graph of modulus function. This is known as the vertex of the modulus function. This is the vertex of the modulus function. This is the positive side where x is positive, it is x is negative, right? So this is the required graph. Now let us talk about domain also. Domain is all real number because every real number you can define this. And then range. Codomain is also real number. Range is what? Range is what? You can easily see from the graph also. From the graph also you can see the range. See, range starts from 0. It can obtain the value. Output can be 0 only. And then above x-axis means all positive. So it should be either 0 or positive real numbers. So it will be 0 to infinity. You can write it like this. This is one of the way, right? Yeah, you can write non-negative real numbers, right? So like this, this is the graph of the modulus function, right? So now we'll be coming to the next graph. Next graph is also very important. Next graph is called signum function, signum, right? Signum function. So what is that function? First let us see. Number 6. Signum function. A function f from a real number to real number such that f of x equal to 1 if my inputs are always positive. I'd like to consider this as 0 if input is 0 and minus 1 if input is negative. That means the real number has been divided into 3 categories of numbers: positive, negative and 0. If I have any positive input, maybe 1, half, root 3, whatsoever positive, output will be 1. Any negative input, output will be minus 1, 0, 0, right? So here, this time I do not want to draw the table, right? So you try to regenerate the table. I'll draw the graph. Let's see whether you'll be able to pick up the procedure or not. You'll be, I am sure, how we draw. First let us locate 0, right? Let us locate 0. So where will 0 be located? 0, 0, right? Once you put x equal to 0, y will be 0. So 0, 0 is the point origin. Fine. So now locate the other points. First, all positive. 1 is the output, right? Suppose you have taken any point here, positive side. Up to where you have to move. If this is 1, you have to move up to 1. Then if you take 2, 1. If you take 9, 1. If you take 100, 1. If you take 1000, 1. If you take 0.5, 1. If you take 0.25, 1. What does that mean? Whatever is the right side of x-axis to the right of 0, it means in that whatever points you take, always the y will assume value 1. Means it will be at a height of 1 unit from the x-axis. So if you join these points, it will go like this. Anyway, I am not very perfect in drawing the graph. Just understand that. But do you feel that this graph is going to intersect or touch y-axis? No, because touching or intersecting y-axis means x coordinate is 0, and once x is 0, value of y should be 0. That means that point should directly fall at the origin. So it means no matter how close you come towards y-axis, you cannot touch this. So we will be just showing it by a half empty circle. This empty circle concept you got while studying interval in your set theory. So this is the right part. If you do the left part, this time also same thing happened. Anything left, always will fall down 1 unit, means minus 1. So your line will be like this and your equation. your graph will be like this. So this is the graph of signum function. This is known as one of the step function, right? There are many step functions. So this is one of them. So here, what is the domain? Domain is the real number. Every real number you have included, you can see. What is the range? Range means output set. You can easily identify your output contains only three numbers, that is -1, 0 and 1. So this is a finite set which is a range, but this is the signum function, right? Till now I have explained you all important functions. Now one of the very important functions I am going to take, that is called greatest integer function, which is very important, right? I'll explain you, I'll try to make it clear to you. Let's see to what extent. So as for CBSE syllabus, this is the last function. So any extra function whatever I need to explain, I'll do it, but not in this particular video. I'll do it separately. So next is the greatest integer function, one of the most important function. Is number 7, greatest integer function, greatest integer function, right? This is the greatest integer function, जिसको हम लोग GIF के नाम से भी पुकारते हैं, to call it GIF. What does that mean? Let's understand that, right? A function f from R to R such that fx is equal to, remember, third bracket x, third bracket, sometimes, right, sometimes we use another notation, right, that is bracket with like tilt, that below the upper part is not there, because we call it floor function also. Why floor function? I'll explain you. So where this is the greatest integer not exceeding x, greatest integer not exceeding x, greatest integer not exceeding x, मतलब the integer which is greatest of its kind but it does not exceed x. It may be equal to 3, it will not cross that particular limit. Did you understand? Now this whole thing can be also written as, right, simply that integral part of x, integral part of x. If it is a decimal number, say 1.2, 1 is the result here. So I'll explain that, then we'll go for the graph. Say somebody asks you to find 1, 2, greatest integer function. So number lines we put it here, then it will be easy for us to understand. 1.2 will be lying somewhere between where 1 and 2, right, somewhere here. Say this is the position for 1.2. Now without going bigger than 1.2, without exceeding 1.2, you find all the integers. So that will be obviously in the left side. So what is the greatest of all that? That means it is just the integer to the left, immediate left of 1.2. That will be 1. So your value should be 1 here, right? Similarly, if tomorrow somebody tells you that I need the greatest integer function of value for 3.1, what will it be? 3. Just the left. Very fine. Suppose that I ask you what is the greatest integer value of -1. Will it be minus 2? Because minus 2 is immediately in the left of minus 1. No, it will be minus 1 itself. If it is an integer, output is the integer itself. Why now? Now try to understand why is it so. The very reason is that we have told you create this integer not exceeding x. It should not exceed x, but it can be equal to. Right? So if you are considering minus 1, then minus 1 is not crossing minus 1. It is equal to it. Is that clear to you? So that is a very important concept to get very importantly clear. And before I go for the graph, let me talk about one more point. Suppose you are talking about minus 1.5. So minus 1.5 will be lying between minus 2 and minus 1, exactly in between. So now if somebody asks you about the value, greatest integer value or integral value of this, if you do not look at the graph, you may have a temptation to say it to be minus 1, which is wrong. Look at the graph. The point 1.5 is here. So just immediate left the integer is minus 2. So minus 1.5 or minus 1.8 will be giving you minus 2 as the value. Am I clear to you? So please pause the video for some time and think over it, because this is very important problem, right? So now let's draw the graph. But before drawing the graph, we have to do some preliminary exercises, work. Then only we can draw the graph. Otherwise, we will not be able to draw the graph of this function. It will be difficult. See, I'll draw a real number line first. I'll explain you first. Then we'll transcript directly this into the graph. Real numbers 0. See, we have to work on integers here. So we'll mark basically all integers. We'll mark basically all integers. Right? Suppose you are taking 0. What is the greatest integer value? 0. Fine. You are taking 0.1. What is the greatest integer value? 0. Taking 0.5. 0. Taking 0.9. 0. Taking 0.99. 0. Taking 0.1. 1. That means what did you notice? When you take 0 and up to 1 you go, but you do not take 1, then for all these value belonging to this, greatest integer value is always coming out as 0. Right? Similarly, observe. If you pick a point 1, 1. 1.5, greatest integer value is minus 1. 1.9, greatest integer value is 1. 2, greatest integer value is 2. That means if you consider 1.99, maybe for 10 lakhs time, greatest integer value will be 1, not 2. So that means x, if I pick up from 1 to 2, then greatest integer value is 1. Similarly, now you can make a trend and you can easily identify that this way we proceed. So this is what preliminary work we have to do. Now here only, before I proceed further, I'll tell you why we call it floor function. We call it floor function, right? We call it floor function because see, if my interval is 0, 1, always here our discussion is on the unit interval, matlab those intervals which has length 1 unit. Lower point is considered as a result. Lower point, left side. Ground, floor is down, ceiling is above. Floor, we are considering the floor. So because of that, we call it sometimes floor function also. Right? Floor. No, not this is not double O, it is floor function. F-L-O-U-R, floor function. And we have the alternative symbol, as I told you. Instead of writing the box, we can write it like this. Right? Floor function. Floor. Right? So if floor function is there, there will be ceiling function also. That is your job. That I'll do in the other video, but it is your job. So now we'll be drawing this in the graph. I'm drawing the graph here. It's a very nice graph, right? It's a very important as well as very nice looking graph. See, your intervals are unit intervals, so very precisely you have to divide x-axis in unit intervals, right? Otherwise your graph will not be correct, right? -1, -2, -3. Similarly, this will be also divided into unit. QP, your results are integers here. Your results are integers here, right? Either 1, 2, -1, 0, etc. Right? So here you see how we proceed. Be very attentive. Little time is there to finish with this video. If you take any point from 0 to 1, your returning is 0. Means y-axis you don't go anywhere. You will be lying on the x-axis only. But remember here 1 is not being included. So how do we mark it? We will make a half circle, empty circle, and then this will darken. This will darken. Next part. Here 1 but up to 2 will not touch 2. So if I draw a dotted line like this, I have to take values from 1 to 2, then return is 1. Means along y-axis I have to go one step up. So my values will be starting here, but I cannot touch this dotted line. So it will be looking like this. Next 2 to 3, if you draw a dotted line just to track, it will go for one more step, 2. Then if you go for 4, what will happen to this? You will go one more step, right? See how nice it is coming. Now next, whenever you are considering left side, it is going like this, and it will not include -1 this side. Then if you go for the another step, it will go like this, right? So this is the graph. Now what is the observation here? See, is it looking like a staircase? So it is also known as one of the step function, whose name is greatest integer function, or we call it floor function. प्यार से बोलते हैं इसको, right? But remember, this is a very important function. Now coming up to the domain and the range, the last part to be discussed. Domain of this function is as usual real number, and range, right? If you observe carefully, what is the output nature? No matter whatever you are giving as input, your output is always integers, right? So range is always the set of integer, right? So that's it for today. We have finished with the graph. In the next video I'll be taking the problems of functions and we'll finish it. We'll wipe it, right? Bind it. Okay, thank you so much and all the best.